Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered why some things just feel like they should go left to right, or maybe right to left? Well, today we're diving into how your reading habits might be shaping how you see the world, even when numbers aren't involved. Imagine this, your brain is constantly mapping things in space. For a lot of us, smaller numbers are on the left, and bigger numbers are on the right. This is called the SNARC effect, and it is pretty solid. But what about things that aren't numbers, like how fast something is moving? Can culture also play a role in that? That is exactly what this fascinating study wanted to find out. So the big question is, does the way you read and write make you see motion differently? Think about it. When you read, your eyes move in a specific direction, left to right or right to left. Does that directional movement get wired into your brain in a way that influences how you perceive other directional things, like movement itself? The researchers decided to put this to the test by looking at two groups of people: Italians who read and write from left to right, and Iranians who read and write from right to left. They wanted to see if this difference in writing direction would lead to a difference in how these groups perceive the speed of something moving on a screen. We already know that in many Western cultures, there is this strong connection between numbers and space. Small numbers feel like they belong on the left, and big numbers on the right. This is what the SNARC effect is all about. Now, this is where it gets interesting. For numbers themselves, some previous studies had shown that people who read right to left, like in Iran, should have their numbers mapped differently, maybe right to left too. But some newer studies on Iranian participants actually showed a regular left to right number space mapping, which made scientists scratch their heads. So, the direct link between reading direction and number space mapping was a bit fuzzy. But what about things other than numbers? Research has shown that this spatial mapping isn't just for numbers. We also tend to map things like time and even physical size onto space. This suggests we might have a general system for understanding bigger or smaller amounts across different types of information. This is where visual speed comes in. It is not a number, but it is definitely tied to movement through space. And movement has a direction. So the researchers thought maybe, just maybe, the direction you write could influence how you spatially represent movement itself. To test this, they basically ran a carefully designed experiment. They showed participants on a screen what are called random dot kinematograms. Imagine a bunch of fast-moving dots on a screen, kind of like watching a snowstorm, but the dots are all moving in the same direction and at the same speed. The job for the participants was simple. They were shown these moving dots and had to say as quickly and accurately as possible whether the speed was faster or slower than a reference speed they'd learned. They did this by pressing a key on the left or a key on the right. They tested 30 Iranian participants for this part of the study. They made sure to match the experiment closely to a previous one done with Italian participants. And they had a really specific number of trials to make sure their results were reliable. The setup was pretty standard for a psychology experiment. Participants sat in front of a computer screen, and the experiment ran using special software. The key thing here is they were seeing these moving dots and had to give a left or right key press. The stimuli were these random dot displays, and crucially, the dots were moving randomly in direction 360 degrees around. This wasn't about seeing them move strictly left to right or right to left on the screen itself. This was to isolate the idea of speed, not a particular screen direction. So, the core task was faster or slower, press left or right. And here is where the magic happens. When they looked at the results, they found something really striking. The Iranian participants who write right to left showed a pattern where slower speeds were responded to faster with the left key, and faster speeds were responded to faster with the right key. Wait, let me rephrase that. For the Iranian participants, it turned out that slower speeds were associated with the left side and faster speeds with the right side. This is the opposite of what you'd expect if everything was left to right. It is a right-to-left mapping for speed. Let's break that down. In the Iranian group, when the dots were moving slower than a reference speed, they tended to hit the left key faster. When the dots were moving faster, they tended to hit the right key faster. This suggests that for them, the idea of slower is linked to the left and faster is linked to the right. This is a right-to-left association. Now, they directly compared this to the Italian participants from a previous study by Vicovaro and colleagues. And guess what? In the Italians who read left to right, they found the opposite. Faster speeds were more associated with the left and slower speeds with the right. This means while Italians seem to map speed left to right, Iranians are mapping it right. Toe left. This strongly suggests that the direction in which you learn to read and write really does influence how you spatially represent other concepts, especially those that involve direction and movement, like speed. It is like your brain learns to associate the direction of your pen strokes with the direction of motion. And this is super important because, as we mentioned when it came to actual numbers, the research on Iranian participants was a bit mixed. Some studies showed a left-to-right number space mapping, even for people who write right to left. This new study says that for something like speed, which is inherently about motion, the writing direction might have a stronger, clearer effect. This fits with a theory called CORE, which stands for correlations in experience. It suggests that our reading and writing habits shape our mental maps, but only for things that are directly related to that writing experience. So, since writing involves moving your hand in a direction at a certain speed, it makes sense that speed itself would be affected by your writing direction, more so than abstract numbers. To dig a bit deeper, the researchers also gave the participants a questionnaire about their general directional preferences. This questionnaire asks about how people tend to arrange things in space, like drawing or imagining movements. Interestingly, in their Iranian participants, they found no strong clear preference for either left to right or right to left at an explicit. Conscious level, they were pretty much neutral on average, even though they were living in Italy at the time. This is cool because it shows that even if people don't consciously think I prefer right to left, their behavior in a task, like judging speed, can still show that influence. This dissociation is key. It means that the unconscious spatial mapping of speed can be influenced by cultural habits, even if people aren't aware of having a directional bias. The implicit or automatic mapping is showing a difference, even if the explicit or conscious preference isn't. So, why the difference between speed and numbers? The researchers think it is because writing itself is a direct experience of motion and direction. When you write, your hand moves across space at a certain speed. This direct connection makes its impact on speed perception more pronounced than on abstract numbers, which might be influenced by other factors. So, what is the big takeaway here? This research strongly suggests that the direction you learn to read and write actually shapes how you mentally map concepts like visual speed onto space. It is not just about numbers. Even motion itself can be influenced by your cultural background and how you interact with written language. Now, for a bit of critical thinking, this was a well-designed study directly comparing two groups with different writing systems. The use of random dot kinematograms helped isolate the effect of speed itself, rather than a screen-based direction. The participants were also screened to ensure they were from the intended cultural backgrounds. One potential limitation, as the authors themselves point out, is that all the Iranian participants were living in Italy at the time of testing. While their explicit preferences didn't show a strong bias, living in a Western culture could still have some subtle influences that are hard to control for. Also, the study focused on speed, and it would be interesting to see if other non-numerical magnitudes, like loudness or temperature, also show similar cultural modulation. This research opens up some really exciting avenues. It highlights how deeply ingrained our cultural habits can become, influencing even fundamental perceptual processes like how we understand speed. Future research could explore this more broadly across different cultures and a wider range of non-numerical magnitudes. Could this influence how we design interfaces, educational materials, or even how we understand learning difficulties? It really makes you think about how our everyday experiences, like reading a book, can shape the very way our minds process the world around us. So, next time you are watching something move, fast or slow, just remember your brain might be using a map that was drawn by the direction of your pen. Pretty amazing, right? What do you think about these findings? Does this resonate with your own experiences? Let me know in the comments below. And if you found this interesting, be sure to hit that like button, subscribe to RUBIN'S Mind Lab for more brainy insights, and ring that notification bell so you don't miss our next adventure into the human mind. Thanks for watching!